sensors.
Good evening. This isn't really the best time of the year for stargazing because there's not enough darkness. And also, we've now lost the brilliant planet Venus from the evening sky. But after midnight, we do at least have Saturn, which is in Sagittarius, the Archer, not too far from the bright red star Antares and the Scorpion. Well, Saturn, I'm afraid, it's rather low down. It's brightish, but it does skirt above the horizon at the moment. It's well south of the celestial equator. But to make up for that, its lovely ring system is wide open. And this is how I saw it recently with my 15-inch reflector. Now, the last probe to bypass Saturn was Voyager 2, which has since then passed Uranus and is on its way to Neptune and then out of the solar system. So I think this may be quite a good time to look back at what the probes have told us over the last few years and also what's going to happen in the immediate future. And we are delighted to have with us once again Dr. Gary Hunt. Welcome back, Gary.
Hello, Patrick.
It's been an exciting time, hasn't it?
An amazing 25 years, Patrick. Now we've seen everything from Mercury to Uranus and the chance of Neptune too, with technology which has gradually been advancing. So we've had a chance to look from a distance and now close up and indeed land, as we did on the case of Mars. A wonderful period, a period we're never going to repeat quite so effectively in history.
I fear we're not. Well, of course, it really goes back to 1962. That was the first successful interplanetary probe, Mariner 2, which went past Venus. Well, Mariner 2 didn't actually send back any pictures, but we've had plenty of space pictures of Venus since then, and here is one, and you can't actually see through the atmosphere. And before the space probe era, we knew very little about Venus. We know a great deal more now. It's not a very pleasant kind of world. The Russians have landed probes there, and here's a picture sent back from the surface of Venus by Venera 13. You can see there part of the space probe, and the rocks are actually glowing orange in the intense heat, not very far short of 1,000 degrees Fahrenheit. And you add a dense carbon dioxide atmosphere and clouds of sulfuric acid, and I don't really recommend going to Venus. But after all, Gary, the Russians have had tremendous success there.
It's amazing to think that just before those pictures were taken, I was on a committee in the States that said you can't take pictures on the surface of Venus. They immediately proved us wrong. Then with a series of space probes landed all over the surface, had instruments recording data for more than an hour at a time, have sent down balloons, and really revolutionized our understanding of the planet and told us that Venus really is a very highly polluted place as a clear indication of what could happen to an Earth-like planet if in fact misused, and must surely be a very cautionary tale for us all.
How right you are. Well, the Americans have now joined in, of course, but when we come to the other inner planets, it's mainly an American story. Mercury, for example, bypassed so far by only one probe, Mariner 10, and there's a Mariner 10 picture showing Mercury's crater-scarred surface, a world not too unlike the Moon, and of course virtually without atmosphere. But when we come to Mars, things are very different, and there's an Earth-based picture of Mars taken from the Lowell Observatory some years ago. You can see there the white polar cap and the dark areas and the red deserts. And incidentally, this autumn, Mars is going to be almost as close to us as it can ever get. And you will see it shining very brightly in the southern sky. We'll have more to say about it then. But again, Mars is a long way off, even by planetary standards, and therefore, even with our best telescopes, we can never see Mars better than we can see the Moon with good binoculars. And so before the space probe era, our knowledge was very incomplete. The first good pictures were sent back by Mariner 4, way back in 1965. And there's the best Mariner 4 picture showing the first Martian crater. We do, of course, have maps of the surface, and those dark areas are permanent. They are not old seabeds filled with vegetation, and there aren't any canals. Those dark areas are simply regions where the reddish dust has been scoured away. But we really depend upon our space probes, particularly the Vikings, and, well, just look at this. Mount Olympus, Olympus Mons, a huge Martian volcano, 3 times the height of our Mount Everest, with a 40-mile caldera in the top. Is it dead, dormant, or active? So far, we don't know. Well, the main results from Mars have so far been American. The Russians haven't yet had any luck at all, either with Mars or with its 2 dwarf satellites, Phobos and Deimos. But I think that's going to alter now in the very near future.
I think the Russians are being amazingly daring with the most extraordinary mission they're planning, a truly international mission which involves scientists from all over the world, including Americans too. And that in fact is to Phobos, this extraordinarily irregular shaped object. You can see it's just about 20 kilometers across, heavily cratered, possibly a fragment of a larger object. A big question is, where did it come from? Is it something that was born out of Mars, or was it captured? And this mission, it really is going to be amazing because it's going to send a probe later this year, flying, indeed hovering, just above this tiny little satellite, no more than about 15 meters above the surface. It'll be sending down laser beams to sample the soil, other measurements to understand exactly what the soil is like, and then dropping down what they call a rover. I would like to call it sort of a cosmic kangaroo, because as you can see, it hops around, and every time it stops, it takes some samples of the soil and will give us an indication of what the surface of these satellites are like. Because Phobos and its sister satellite Deimos may in fact be very important to us. They could be carbonaceous chondrites, or they may relate directly to the origin of Mars and may have formed out of the planet. But this major mission, a very daring mission, I think is going to really revolutionize our understanding of these satellites.
I'm quite sure it is. And of course, don't forget Mars itself, the balloon experiment, which is quite fascinating.
Well, there's some wonderful things developing for Mars itself, because we're doing some work at the moment in the deserts of North America, in fact in Nevada, where this large black balloon, heated by the sun, will rise and of course at night will fall, and it's kept above the ground by a helium boom above it. And dragging along the surface, and this is to simulate what Mars is like, is this snake-like object. And it's a very long snake, so it doesn't get trapped in some of these rather sharp boulders that can exist on the surface of Mars. And inside the snake, a whole set of instruments, in fact, to study the surface properties of Mars itself. Now, also going to be attached to that tether in time will be a very small camera. And you can see this one that's been developed in France, and it'll be taking digital pictures around the surface terrain of Mars as the balloon drifts around, so that they can ultimately be computer processed to tell us more about the surface. But this is a wonderful way to see as much as Mars as possible. The two landers we had from Viking told us about two particular places. The balloon will drift around in the winds and tell us more about Mars on a large scale.
The humble balloon comes into its own, just as well that Mars has got an atmosphere. You couldn't do that balloon experiment on the airless moon.
No, and in fact I think the important thing here is that we're understanding about Mars on a global scale, and hopefully it won't get caught up in these massive dust storms, but even so, it would tell us more about how the winds suddenly change from a few miles an hour to very fierce winds. So wonderful opportunities for missions, joint missions in the future.
Well, let's turn now to what we've learnt about the outer planets, Jupiter and beyond. And of course, the most important probes there have been the two Voyagers, both American. Well, Voyager 1 was launched in 1977. It bypassed Jupiter and used Jupiter's pull of gravity to send it on to a rendezvous with Saturn. It also studied Titan, Saturn's large satellite, the one with a nitrogen atmosphere. And it had to do that, which meant it couldn't go on to any other planets and is now on its way out of the solar system. Voyager 2 was actually launched a few days before Voyager 1. It was traveling in a less economical path and bypassed Jupiter a few months later. It also then went past Saturn, didn't bother about Titan, that had been done, and it went on to a rendezvous with Uranus in 1986, and is now on its way to a pass of Neptune in August 1989. It also will then go on its way out of the solar system permanently. But both those voyages have been outstanding successes, and they've sent back magnificent pictures. The first, of course, was Jupiter. And here's a Voyager 1 view of Jupiter, showing the belts and the zones and the great red spot. Very much more detail than you could ever see from the Earth. But there is one thing we've got to bear in mind. Jupiter is nearly 500 million miles away from the sun, and there isn't much sunlight out there. So you can't use solar power to power your probe. You've got to develop entirely new types of technology.
And of course the Voyagers, and this is a model here, in fact, have been the most marvellous package of the most advanced technology we had available. On the back here is this power pack which gives the energy, and it's slowly decaying with time, but still enough energy to last all the way out on its mission. But it has several onboard computers which take the sequences, control all the spacecraft. But the important thing is they go wrong, like motor cars, they go wrong from time to time. You may remember this scan platform down here, which contains several instruments, and particularly the cameras, malfunctioned at Saturn. Yeah. And in that gap between Saturn and Uranus, the engineers wrestled with the model on the ground, understood how the mechanism worked, and corrected it before it got to Uranus. So here's a spacecraft aging with time, built with the technology of the late 60s, which has been repaired several times as it's moved out of the solar system and still is working in readiness for Neptune. But not also the spacecraft, but on the ground there have been developments as well. Each of the ground stations for the Deep Space Network in Australia, in Spain, in North America have been upgraded to receive these weak signals. And of course we're receiving important data which is used on computers. One of the problems is storing it. We have so much of this data. In the past it's been on computer tapes. And Patrick, one of the exciting things that's come here is that although computer tapes are wonderful ways to store data, they occupy a lot of space. This has the equivalent of 400 large magnetic tapes to contain all the images around the Uranus encounter. And it's a major breakthrough. Some of you may recognize it. It's a CD-ROM. You're used to having it to play your music. But now it's the revolutionary way to compactly store data for analysis on computer systems. So Voyager, old technology perhaps of the spacecraft, but very advanced technology, spearheading some of the developments in computer storage and indeed the way we analyze our data. A magnificent mission and indeed a lesson for us all.
It is indeed. But after all, Gary, you're essentially a planetary meteorologist. What have the probes told you about, well, Jupiter's weather, for example?
Well, indeed, all these planetary missions have changed it from being a qualitative science where we look at pictures and say, well, the weather systems have changed from one day to the next, into a quantitative science and we can say something very definite about it. In the case of the outer planets, which we hadn't really studied much before, we've suddenly been able to understand the weather systems, the speeds, how particular cloud systems interact and rotate. And we now know that Jupiter and Saturn and Uranus have weather systems rather like the Earth, even though these are planets, some of them with internal heat sources. So suddenly this has become a real science. So I think the important lessons we have learned have really improved our understanding, not only of these planets, but weather systems in general, and certainly helping us to predict and understand weather phenomena within our own Earth's environment. So planetary science has been extremely important in that way.
Well, Jupiter obviously had to be the first. It's the nearest of the giants. Beyond that, Saturn, with that magnificent ring system, which Voyager showed us wasn't a bit what we expected. I don't think many people expected those thousands of ringlets and narrow gaps. And then there are Saturn's satellites, icy Mimas, with one huge crater. And then the most fascinating of all, Titan, bigger than our moon, with a dense nitrogen atmosphere. And then beyond Saturn, Uranus, strange green tilted planet, again with a family of satellites. And of those, I think the most fascinating is Miranda, a small world. This is a mosaic of it. What do you make of that, Gary?
That's the question I was asked, Patrick, when that picture came up on the screen for the first time at JPR.
Yes, I remember.
And my feelings are very much the same now. It is the most extraordinary body. What other object could have such a ragged edge as that? It looks to me as obviously a satellite which is inside out. It must have been smashed apart, held the material in its own weak gravity, and then reassembled. How on earth do you get sort of a varied terrain as that? It really is the most extraordinary place, but clearly the star of the Uranus encounter.
Oh, I'm sure it was. The trouble is we're not going to have any more Uranus probes for a long time, and only Voyager 2 out to Neptune. But at least things are rather better so far as the inner planets are concerned. And we do have the Magellan probe to Venus, which is almost ready to go.
Well, in fact, this is the start of the reactivity for planetary exploration. We've been waiting for the shuttle program to get going because most of these future missions rely upon the shuttle system to get going once more. We've had Pioneer Venus. It's been up there 10 years. It's still giving us pictures of the planet and continue to map the surface. And our mapping of the surface so far has told us that there are a whole range of what we think of volcanoes, and we don't know if they're active or not. There are huge plateaus. There are a large number of rift valleys. But really, with a resolution of just a kilometre, we can just say that's the sort of geological formations that are there. We would really like to know what caused them, how did they develop. The new mission, the Magellan mission, to be launched on Atlantis as soon as possible, and we hope indeed in October of this year, if we're lucky, will in fact take the resolution from a kilometre down to about 100 to 200 metres over the entire range of Venus. So here is an opportunity to put the geological understanding into a much greater stage than we have at the moment.
But at least Venus really is close. I mean, it can come within 25 million miles, which is closer than Mars ever gets. And one thing you haven't got to bother about really, I think, round there, is stray asteroids. But when you start going out to the giant planets, you've got to go right through the asteroid belt between Mars and Jupiter. Well, there are plenty of asteroids, and although there have been no disasters so far, I think that the NASA planners were very worried about the asteroid belt initially when they started sending probes out beyond it.
I think they're still worried too, Patrick, because they've all got through so far, but on the other hand, is that just luck? Are they going to meet something? It doesn't have to be a very large object. A tiny little speck of dust hitting one of these spacecraft moving at 20 to 30,000 miles an hour really could be a catastrophic event. So we've been lucky so far, and I continue to hope that they will always be lucky, but we've just always been worried. We don't really know all the asteroids out there, because some of them may be so small we haven't actually spotted them yet.
Of course, but for the Challenger disaster, we'd have got a close-up picture of an asteroid by now, because the Galileo probe out to Jupiter was scheduled to take pictures of asteroids on its way. But at least the Galileo probe has been delayed, but it is now scheduled.
at last, Patrick, it's going to go. And I think that's the feeling that all of us have had. Some of the experiments were selected in the late 70s. The mission was expected to be over at the early 80s. And now we're looking forward to a launch, hopefully towards the latter part of next year on Discovery. But it's not a prime time to go to Jupiter. So it's the most extraordinary route. First around Venus after its launch in November 89, and by February 90 it goes around Venus, back around the Earth by December 1990, and then around the Earth once more to get enough energy by the time December 1992 comes up, in order to move off to Jupiter, which it finally reaches in about the middle of 1995. So it's a very long journey with this Delta Vega path out to the Jovian environment. And then we have a chance to really change our understanding of Jupiter, because this is not just a regular flyby, it's a probe to go right the way through the cloud systems to tell us about Jupiter itself, and this amazing orbiter that's going to be building up information about the whole Jovian environment. This is the most amazing flyby, which whirls in close to all the satellites, building up in a petal-like way our understanding of the satellites. And as you can see, each of the satellites will be distorting the orbit, bringing it in closer, moving around over a passage of about 2 years, a whole collection of different ways of observing that system. So we'll be able to improve our resolution of the satellites down to a few meters, see all of them, see the whole of the Jovian environment. A mission worth waiting for. Indeed, it's a pity we've had to wait so long.
It is indeed. But of course, the Galilean satellites are so different. I mean, there's inert, icy Callisto, and then Io with its red surface and its active volcanoes. What do you make of Io?
Well, certainly the largest pizza in the solar system from what we see at the moment. And we know that at the time of Voyager there were 9 active volcanoes, but we can't really say much more than that. I think the Voyager really set more questions than issues it actually answered. And we're hoping that Galileo, with his regular interaction of the satellites, very high resolution observations, are really going to start to answer it. So this is something to be looking forward to.
Well, Galileo will end at Jupiter, but then with Saturn we have the Cassini mission, and that's now scheduled for the mid-1990s.
Cassini, I think, is the most exciting mission of all. At the moment, a joint study between NASA and the European Space Agency. And this, again, is a mission that's got to fly through from Earth through the asteroid belt. It's going to be a launch in the middle 1990s. And after one trip through the asteroid belt, finally it gets out to Saturn in the year 2002. A marvelous way to start the next century. But, of course, this, again, is a probe and a flyby as well. The flyby will be going around and orbiting around Saturn, rather like the Galileo probe. But the probe in itself is going to go to Titan, because we really want to understand what this nitrogen satellite is like. Indeed, we'll be able to sample the probe as it goes all the way through from the top of the clouds, slowing down because of the atmosphere itself. The chute will be deployed. We're taking measurements right the way through the atmosphere, the clouds, the aerosol layers, down to the surface, which it reaches in about 180 minutes, to discover what the surface is like. Is it going to be liquid, Patrick? Is it going to be icy? Is it going to be rocky? We don't know. I think this is the most exciting mission of all time, a marvelous way to start the next mission.
Will Titan be like this, with Saturn shining dimly through the orange clouds in the nitrogen sky? I wish we knew. Well,
I'm surprised if we see the sky as easy as that, but we'll wait and see.
Well, beyond Saturn, Uranus, no more Uranus probes, but we do have Voyager 2 passing Neptune in August 1989, and I wonder what that's going to tell us as it flies by the planet and its satellites.
Well, the important thing is that Voyager is in great shape. We've already got pictures back from Neptune, and they look very good, and we know the spacecraft is very healthy. This must be the most exciting flyby of all, over the North Pole of Neptune, on to see Triton, and who knows what Triton's going to be like. Are we going to see breaks in the cloud? Are we going to see the surface? Or is it going to be so covered in cloud like Titan? Who knows? But the important thing is that 1989, 12 years after launch, Voyager is still working, and we know it's going to give us stunning measurements again.
Well, as you said, Gary, it's been a great time. To sum up, what do you think is going to happen in the immediate future? Base it on the moon and Mars?
I think that's already been discussed at the recent summit between Reagan and Gorbachev. There's an opportunity to have cooperation between these leading nations, an opportunity to work together, perhaps to have man-building bases on Mars and indeed on the moon. Well, that's something to look forward to in the future.
I only hope we see it. Meanwhile, we do at least have Neptune, August 1989, and the Skynet's going to be there, and you and I, Gary, will be over at the mission headquarters in JPL, Pasadena, California, commenting, and I think we're going to be excited at what we see. We can hardly wait for that also. Gary, thank you very much.
Thank you.
And for the moment, from Gary and myself, good night.